We are going to begin with the third chapter of your NCERT of KISS, that is kinematics or motion along a straight line, which we call it as motion in one dimension. Of course, to get the introduction first, that we have to talk about the motion of the objects, in which is of course very important thing in your life. And the first thing which was given about the motion came into the picture, that was, you have already heard the names of Galileo and Newton. They have contributed a lot in understanding the motion, and this all happened in 16th and 17th centuries. So you should know what is mechanics. Mechanics is of course the branch of physics that deals with the conditions of rest or motion of the material objects around us. So this is important for you to note, that mechanics is a branch of physics in which we are dealing with the conditions of rest or motion of the material objects which are around us. So mechanics we can divide into three categories. One is statics, another is kinematics, and the third one is dynamics. Statics is simply dealing with the objects at rest or in equilibrium. As you have studied in your 9th class, maybe that an object can be at rest, like book on your table is at rest, though the weight is acting downward and normal reaction is acting in the upward direction. So it means body is under the action of multiple forces, but still it is not changing its position, that is at rest. So that branch is your statics. In kinematics, we are dealing with the motion of the objects, but we are not considering the cause of motion. It means we will simply study that moving objects and how the motion is getting changed, whether there is some velocity, there is some acceleration, whether the motion is uniform, non-uniform. But we will not consider that what is causing that motion, that how the body is able to move. That we will study in the next branch, that is dynamics, which is dealing with the objects in motion, considering the cause of motion. And of course, you all are aware of the cause of motion, that is the force. And we have one more complete unit with you about the laws of motion, in which we will be talking about the force in detail. And this is in brief, it means mechanics. We are having three branches with us, but at this lecture our focus is on kinematics. It means kinematics, you should know, that is, we have to deal with the motion without considering the cause of motion. So we will be simply studying the motion of the various objects. That is our aim for now onwards. But of course, to just be aware of the things about the motion when we see around us, that it can move along a curve, it can move along a line. Line means rectilinear. It can, like earth is moving around the sun, that is repeating itself, that is periodic motion. It can be oscillatory. When a pendulum clock is there, this pendulum is moving around the mean position, this is oscillatory motion. Similarly, body can move in the circular path, that is circulatory motion. And translatory motion is nothing but the three-dimensional view of your rectilinear motion when we talk about the three dimension. Similarly, circular motion in three dimension, when we talk, it becomes rotational motion. So all these motions we have to study in class 11th in detail. Whenever we want to study body is in motion or the body is at rest, we should have a reference point with us. Reference point can be anything, like a door of your room, it can be a corner of your this wall. Any point can be taken as the reference point. I can take this point also as a reference point. Means with reference to which I study the motion or I study the movement of the body, that fixed point is termed as reference point. So reference point is simply a fixed point. And when I make a frame having this reference point with me, that is of course in Cartesian coordinates we do most of the times when we are talking about in physics. That is your x-axis, y-axis, z-axis, these three are mutually perpendicular axes. And they all are meeting at a point, that is origin. that is we call it origin as the reference point most of the times, that with reference to origin we measure the motion of the body, and this frame which is consisting of these three axes, this is termed as the frame of reference. So two things, one is a reference point, that is simply a point, and frame is frame consisting of all these three axes mutually perpendicular to each other. We are talking about Cartesian coordinates here, but we can talk about the other methods also, but and according to your syllabus we will be talking about the Cartesian coordinates all the times. So you have to study this thing, that these, if I am talking about only one axis, one coordinate like x coordinate, then it is one dimensional motion. If I am talking about y coordinate, then it is x and y both are required. In one dimension I can have either x, either y, or either z, means any one coordinate if required, then it is said one dimensional motion. And if out of these three, two are changing, like I am changing x and y, or x and z, or y and z, then this motion will be two dimensional motion. But if all the three coordinates are changing, then motion will be termed as three dimensional motion. But basically you have to study, this is the frame of reference, and the change in the coordinates, when I am moving from this point to this point, then coordinates of mine will get changed, and that change in the coordinates gives me the idea about the motion of the body. In general, when you draw on the paper, then you may draw like this: x-axis, y-axis, z-axis. No need to give the three-dimensional view. Then my frame of reference can be of two types. One is inertial frame of reference, another is non-inertial frame of reference. Inertial frame is that frame of reference in which you are saying that a body is at rest or moving with uniform velocity, or we will be stating it further that all the laws of motion, Newton's laws of motion, are being obeyed. That frame of reference is termed as inertial frame of reference. So we will be redefining it in the coming unit also, but this is simply for your reference. Like a train is moving on the horizontal track with constant velocity is an inertial frame of reference. Similarly, non-inertial frame, that is an accelerated frame, that is a frame of reference in which it is accelerated or the acceleration is there, that is termed as non-inertial frame of reference. Like when you have a ride in a roller coaster, then you are in the accelerated frame of reference. This is just to give you the definitions for one-dimensional motion. Like if one out of the three coordinates, it can be any one, either x or y or z, that is changing, then motion is called one-dimensional motion. Like a car is moving along a straight line, or like object is falling under gravity, only y-axis. So one axis is required to specify the position of the object or the change in the position of the object. Two-dimensional motion, when two coordinates are changing, like I have written circular motion, or you can say when you play the carom, then the motion of your striker on the carom board is again a two-dimensional motion. If an insect is moving on the wall, again two axes are getting changed. So if two out of the three coordinates they are changing, then this is two-dimensional motion. So you can quote two or three examples for each type of motion for your understanding. That when you are writing on the paper with your pen, that is again two-dimensional motion. You are using two axes. So that is the best example with you. Three-dimensional motion, if all the three coordinates are changing with respect to time, then the motion is called three-dimensional motion. Like a flying bird, flying kite, you can say the motion of the aeroplane or the motion of the gas molecules. These are the examples for three-dimensional motion. So basically we have to focus on one-dimensional motion in this chapter hours. So this is our focus, motion along a straight line. That is, we will be confining ourselves to the study of the motion along a straight line, that is known as rectilinear motion. Rectilinear motion means motion along a. So we have to define these terms. You are already aware, I think. Rest, if an object is not changing its position with respect to the time. Now this time is very important factor with me. Time means I start measuring the time. At this minute, if I see 9:30, it is the time with me, then I will consider this time as the zero time. And then when I will note at 9:35, I say after 5 minutes where the body has reached. If the body has not changed its position with respect to the, of course, the reference point, with reference point I will see, and with respect to time I will see. Two things I am looking into. So if the object is not changing its position with reference point, of course, and with respect to time, then it is called to be at rest. And if the position of the body is changing with respect to its surroundings means, of course, the reference point, and with respect to time, of course, then it is said to be in state of motion. So it means motion is simply the change in position of the object with time. Like we can see a train moving, we can see a walking man, water flowing. These are the examples of motion. And book kept on your table, that is at rest. Should be knowing this thing that rest and motion, they are relative terms. Relative terms, it means when I want to study rest or I want to study motion, I need to have a frame of reference with me, and with reference to that frame I will see whether the body is at rest or it is at motion. So same body can be at rest. Like when you are sitting in the train, you can say that you are at rest with reference to your neighboring person, but you are in motion with the reference to the surroundings outside the train. So the same person can be at rest, can be in motion by changing the frame of reference. So it means rest and motion we cannot speak without having the idea of frame of reference. So I have simply written that an object which is at rest in one frame of reference can be in motion in another frame of reference at the same time. At the same time, if you observe, the one person can be at rest as well as it can be in motion if I change the frame of reference. Of course, rest and motion are not absolute terms. Absolute terms are those which are not dependent on anything, but this is dependent upon frame of reference. So without talking of the frame of reference, we cannot talk about rest and motion. Now the next heading with you is a point object. What is a point object? Like train is moving between two stations, then train, because the distance from Delhi to Lucknow I have taken is quite large as compared to the size of the train. So train can be taken as the point object. When you are moving through your car or bus large distances as compared to the size of the object, then that object is termed as point object. So you can say an object is called point object if position of the object changes by large distances as compared to its size. So size can be ignored, and so we can call that object as the point object. So if the distance traveled by the body is large as compared to its dimensions means size only, and then that point will be termed as that object can be termed as the point object. This point is very important. We have to take the choice of origin. We want to talk about the path length. Path length means distance, and we want to talk about the displacement. Position we have already defined, that is a point where an object is situated. You can find it here. This on one dimension, when I am here, I have taken only the x-axis, and this is if I am taking as the zero position is termed as the origin. When I am moving to the right side, that is taken as the positive direction. When I am moving to the left side, it is taken always as negative direction. This convention is always clear to you because you do it in mathematics also, that on the right it is taken as positive, left it is taken as negative. So if my object is here at this position, then it is having the positive coordinate. If I put the object here, then it will be having the negative value. Like if the object is here at -1 meter, then minus sign is simply saying that it is along the negative direction. So position is what? It is the point where an object is situated. So it can be determined by the coordinate axis on which we are marking the unit of length. We can mark like you do the graph plotting. Same way we can assume this is 1 meter, 2 meter, 3 meter at equal distances. Equal values can be given. So we can make a scale and we can put the values on the positive side, on the negative side as well. So this is about the choice of origin. When you are aware of the choice of origin, we can talk about the distance. Distance you have already done. That is the actual path covered by a moving particle in a given interval of time. So if supposingly at time t equals to 0 minute I am here, at 1 minute I am here, then at 2 minutes I am here, 3 minutes I am here. So what is the total distance traveled by the body? You have to simply add the things. So at 0 you are starting, 1 minute you are covering 180 meter. Then in the second minute you are covering 140. You can see the values are given. And then in the third minute you are covering 100 meters. So what is the total path length? That you can say 180 plus 140 plus 100. It is coming out to be 420 meter. Of course, it is a scalar quantity because we are not considering the direction when I am finding the distance. That is simply the total path length or the actual path covered. Dimension distances will be of same as that of length. So m0, l1, t0. And if I talk about the SI unit, that is meter. I can write simply by small m the distance. Now when I talk about displacement, that is the shortest distance between the initial and final position of any object during the motion. Now if I am starting from origin, say at t equals to 0, I am at origin only. And at t equals to 1 second I reach at a point. So this is minus 30 meter displacement. Now if I am not ending here, I am going to B point, then this is plus 40 and this is minus 30. So distance will be yours. You have to take now about the direction also. So displacement will be 10 meters along the positive direction. And further, if you are moving from B to C, then you are moving 20 meters more. It means plus 10 and then moving in the opposite direction, minus. So you have to see this way. If you consider total path length, distance can be calculated, displacement can be calculated. If you want to calculate displacement between the first initial position and the final position, that is of course initially I started from O, finally I am reaching at C. So displacement will be 20 meter. That will be simply the distance between the final position and the initial position. So we will not be considering what path it followed. But if you are asked in between, you can calculate the displacements in between according to the question. And it has been found that displacement in a given time, it can have the positive value, 0 value, or it can be negative also. While distance is always positive. It is of course a vector quantity because we have to talk about the direction. Dimensions are same as that of distance, that is dependent upon length, and unit is of course meter in SI system. These are few points to compare between the distance and displacement. That magnitude of the displacement will be always less than the distance or it can be equal. For a moving particle, distance can never be negative or 0, but displacement can be negative or 0 also. And for the motion between the 2 points, displacement is a single valued, while distance depends upon the actual path, so it can have many values. For a moving particle, distance can never decrease with time, but displacement can decrease with the time, as we have discussed. Magnitude of the displacement is not equal to distance, but if the motion is moving along a straight line and a given direction, means it is not changing its direction, then displacement and distance can be equal also. So this is just to show you that displacement is the distance between the initial and final position, while distance is simply by adding the whole path. You have to add up the things to find the total distance. Thank you everyone.